Okay. So if you are given a concentration of an acid solution and you want to determine the color of an indicator, this is just a reminder from Acid Base Unit 1 that you need to determine if the acid is strong or if it is weak. How do you find hydrogen ion concentration if you have a strong acid? If I gave you 0.1 molar HCl, what is the concentration of hydrogen? 0.1 molar, because it just dissociates completely. Yes? So let's say that this was, if this is our strong acid, and this was 0.1 molar, then our hydrogen ion concentration would also be 0.1 molar, and X would be 0.1 molar, but we wouldn't really care about the X. Okay? And then from there, you could say, okay, what's my pH? And then you could look up what color your indicator changes on the chart. What if the acid is weak? What tools do you need to use? Tell your partner. If it is weak, you need to use rice and Ka. Okay, good stuff. All right. So here's a question. What color is brom cresol green in an 0.025 molar solution of sulfuric acid? So sulfuric acid, you can look it up on your acid chart if you have forgotten what its formula is. It is H2SO4. Is it a strong acid or is it a weak acid? Go look if you don't know. Kevin, do you want a quiet place to work? You're almost done? Okay, cool. All right, is H2SO4 strong or weak? Strong. Strong. So therefore it dissociates completely. And what do we know about a diprotic acid? In a diprotic acid, only the first dissociation makes a significant contribution to H+. So when we write the dissociation, who should be the species that we get? We would get H plus what? HSO4 minus, and because this is 0.025 molar and we are dissociating completely, what is the concentration of H plus? 0.025 molar, and HSO4 is 0.025 molar, although we don't care about that one really. Could you calculate the pH? Are we good with that being 1.60? And therefore, what color is Brahm cresol green?
Yellow.
It is yellow. Oh, yes, certainly. There you go. Anyone confused on why it's yellow, or are we all good? We're all good? Excellent. All right. What color is chlorphenol red in 0.05 molar solution of HCN? Now, what is HCN? HCN is a, feel free to look it up. It is a weak acid. And I'm also going to write acid because soon we're going to be looking at bases, okay? It is a weak acid. And when we are given a concentration, is this the equilibrium or initial concentration? That is the initial. So I got a little obsessed with the pictures. I was like, it was in the other book. You need to see the picture again. And now you get to see it in color. How exciting. They accidentally printed the book in color. Oopsie. Okay, so can you guys do this calculation? Can you show your work and do this calculation? So above 5.4. So row 3.8. Yes. Thank you for asking. Oh, good. Okay, now, just before we go on, it's mostly good. It's equilibrium, not to give. Yeah, when you start this all the way up. Okay, I know. And now all you do is add that. Just minus that. Yeah. Okay, so how do you yes, so that would like pull this and that. So right that. And then go over. Yeah, yes. And right? So product is around this. Okay, and then you'll plug there. Oh. Good. Oh, wow. The only thing is, plus it should be, yeah. Now, when we were in our acid base unit, I didn't make a big fuss about whether you put your states in, but I'm going to suggest that you do that because you've just spent a long time in solubility where your reactants were solids. But in this case, whoops, I don't want HA, I want HCN. HCN is what state? It is also aqueous. It's included in the Ka expression because it is aqueous. So when you write your Ka expression, make sure you're not calling it KSP. We're now back to Ka. Don't forget your ion charges. And because this is aqueous, it goes in your expression. Where can you find Ka for HCN? In the data booklet. HCN. 4.9 times 10 to the minus 10? Okay. How do I make this so I don't have to solve a quadratic? Yes, and I could do that either up here or I can do it down here, and it doesn't matter, okay? So now we've solved for x, yes? And of course, x is our concentration of H plus, but we also need the pH. So our pH, we have 5.31, and then the question asked us, what is the color of chlorophenol red? So we go back here and we say chlorophenol red is, and what did I say the pH was? 5.31. Oh, so what color is chlorophenol red? It's in here somewhere. It's orange, okay, because it's in between the two. It's in between yellow and red. Is good. That was just by way of reminding you how to do these questions, okay? Now, if you are given the concentration of a base, you must also determine if the base is strong or if it is weak. Do you remember what most strong bases are? Metal hydroxides. But now, because you have done solubility, if I give you a low solubility metal hydroxide, you will use KSP to find the OH minus concentration. So we're going to add the word soluble. Metal hydroxide is strong. For insoluble metal hydroxides, you would need to use KSP to find concentration of OH minus. Now, that being said, calcium hydroxide is low solubility. But if I were to say to you, you have an 0.001 molar solution, you have to believe me. You have to believe that I am telling you, you can dissolve 0.001 molar calcium hydroxide, right? If I say, so this is low solubility, but if Ms. Spence says concentration of CaOH two is 0.001 molar, then you have to assume that 0.001 molar dissolves completely. Chances are, what I would say is, if I did want you to mix the units, right, mixing solubilities with this, I would probably say, what is the color of thymolphthalein in a saturated solution of barium hydroxide? Yes? When you hear that word saturated solution, you would think KSP. Okay? But what if I say to you, what color is thymolphthalein in 0.30030 molar barium hydroxide? Do you need to use a KSP? No, because I'm telling you it will dissolve that much. Some of the hydroxides are slightly soluble, which means that although they're low solubility, I can dissolve somewhat. And if I tell you a concentration, you have to assume that much will dissolve. So how would we find the concentration of hydroxide? We would take our barium hydroxide and do what with it? We would dissociate it because it is a solid. It would dissociate into Ba, 2 plus, aqueous, plus 2 OH minus aqueous. If this was the solubility unit, you would need to use an equilibrium arrow. But I'm telling you, you can completely dissolve 0.003 moles in 1 liter. Okay? So that means if I have 0.003 moles, barium is 0.0030. I shouldn't say moles, I should say molar. And hydroxide would be how much? 0.0060 molar. Now we have 2 pathways to get from hydroxide concentration to pH. Yes? Do you remember how to find hydrogen concentration given hydroxide ion concentration? Almost, not Ka, but Kw. Kw is equal to what? Concentration of hydrogen times concentration of hydroxide, because remember, it's for the dissociation of water. So if we want to find hydrogen, what's the formula for finding hydrogen if we have hydroxide? Kw over hydroxide. What's the value of Kw? 1.0 times 10 to the negative 14, unless it specifically says we're at some other temperature, in which case you'll be given some other data. Okay, but we can assume we are at 25 degrees Celsius, and we're dividing that by hydroxide, 0.0060. And we went 1.6 repeater times 10 to the minus 12. The reason I'm keeping that in there is because I still have another step to go, so my sig figs don't really matter at this point. And now I have another step to do. What step comes next? Yeah, you got to find your pH. So we have the negative log of 1.6 repeater times 10 to the minus 12 equals 11.78. And we have 2 sig figs here, so we need 2 sig figs here. Although the answer is going to be like red, yellow, or blue, or orange, or whatever, so it doesn't really matter. Now go to your data pages and look up what color is thymolphthalein at 11.78. We have thymolphthalein is here, and at 11.78 it will be blue. One thing I'd like you guys to take note of, since we're here, and it also starts with thymol, see if you can find thymol blue on here. Thymol blue. There's 2 thymol blues. We have thymol blue here, and we have thymol blue here. So if we are below 1.2, it's going to be red. Okay? If we are above 2.8, it's going to be yellow. And in between it will be orange. Except that we can't say above 2.8 it's just yellow, because once we hit 8, below here, it's yellow. But above 9.6, it is blue. And in here it would be green. Can anyone think how it could have 2 transition points? How is it possible that this thing has 2 transition points? What kind of an acid is it? There's 2 protons. It's a diprotic acid. So when it's doubly protonated, it's one color. And then when you lose one of the hydrogens, it turns a second color. And when you lose the second hydrogen, it turns to the third color. And if any of you did that little equilibrium thing, you remember when we had the equilibrium thing with the little lab where we just did, like, you picked one and you did it? No. Okay, nobody remembers it. Anyway, your little indicator changed from yellow to green to blue, and then from blue to green to yellow. That was thymolphthalein. Okay? Alrighty. So anyway, thymolphthalein would be blue. Let's go back here. Whoops, that's not what I wanted to do. I wanted to go here. There we are, and I wanted to go here. Therefore, thymolphthalein is blue. Excellent. What is the other direction we could go? Instead of going from OH to H, we could go from OH to POH. So that would be the negative of the log of the hydroxide. So that would be the negative log of 0.0060. Which is 2.22. And then how would we find the pH? pKw. pKw is equal to pH plus pOH. So pH is equal to pKw minus pOH, which is 14.00 minus 2.22, which is, guess what? 11.78. It doesn't matter which route you take, you'll get the same thing, and then you would say thymolphthalein is blue. Is good? Okay. Soon we will learn how to determine the pH of a weak base solution, but since we haven't covered Kb yet, we won't deal with it on this worksheet. So there will be some other things on here. Oh, look, what are we going to do? We're going to find the color in a mixture of indicators. Do you guys want to see if you can do this one on your own? Just to see if you can figure it out? We have 3 indicators which are present. We have phenolphthalein, neutral red, and methyl red. And we want to know what color a mixture of all of those 3 will be at pH equals 6.4. Did you get that phenolphthalein is colorless at 6.4? Yeah? Okay, phenolphthalein below 8.2 is colorless. And we also wanted, whoopsie, neutral red. So you go look up neutral red. Below 6.8, it is red. And methyl red at pH 6.4. Methyl red at 6.4 is going to be yellow. So if we have a mixture of these 3 indicators, the solution is going to be what color? Orange. Yellow and red make orange. No, just write orange. The fact that phenolphthalein in there is colorless does not make it any more concentrated or more dilute. Yeah? Okay, now this next part is long and frustrating. Okay? So I think it would be a very good time for you guys to go take a 5-minute break. okay, before we start on this next little bit here, okay? Oh. All right. So we're going to start on this today. We won't get all the way through it. Your homework isn't going to be related to this anyway, because what is your homework going to be? Study for your test. Does everyone have the overall review for your test? Yes? Excellent. Okay, so we have a lab, and if we have time, we might do this lab or we might not. We'll see. There's some other more interesting labs. This one, you just drip things. It's kind of pretty though, so maybe we'll just do a little bit of it. Okay, a lab is performed in which we have 3 indicators. Okay, 3 different indicators. We have HIN1, HIN2, and HIN3. Okay, and we add these indicators into, now what we would have is we would have like a little spot plate. Okay, and what a spot plate looks like is it looks like this, and I would have HCl, it's supposed to be an N. I would have NaOH, HA1, and HA2. Okay, and these just have little depressions in, have you used a spot plate before? Maybe in grade 10? Okay, they're just, you can put a few drops of things in it. So all of these ones in this column contain HCl. All the ones in this column contain NaOH. All the ones in this column contain HA1. And all of these contain HA2. And HA1 is a weak acid, and HA2 is another weak acid. And we get the following results. Oh, I've put the table the wrong way, but that's okay. It's okay. If I have HCl, HIN1 turned red. Okay. HCl and let's see, this is HIN1. This is HIN2. And this is HIN3. HCl turned HIN1 and HIN3 red, and it turned this one yellow. NaOH turned HIN1 yellow. It turned HIN2 blue. And it turned HIN3 blue. HA1 turned HIN1 red. HA1 turned HIN2 yellow. And HA2 turned HIN3 red. And HA2, we got yellow, yellow, red. So we have yellow, yellow, red. Did I do that right? Yeah, okay. Oh, there's an HA3. Oopsie. And HA3, yet another weak acid. Okay. HA3, we got yellow, blue, red. Okay. Yellow, blue, and red. Had I known I was going to get color, I would have drawn this for you, but I mean, you would have just gotten shades of gray normally, so it didn't seem worth it. Now, in this lab, had you done a lab like this, you would be asked to determine the relative strengths of all the acids. So all of our acids, there should also be, let's make this a 2, let's make that a 3, and let's put HA1 over here because I goofed up on that. And we're going to put them all in order from strongest to weakest, just like we did, just like on our data table, from strongest to weakest. Are we good with that? Okay. Now, I'm going to keep repeating this data table because we will use this data table on the next page. So we can set up equations for what happens in each of the mixtures. So we have HCl, which is really HCl and Cl minus, yes? And we have HIN1 and IN1 minus, because remember the indicator is both of those, and we get the color red. Now, HCl is an acid, so it must react with which form of the indicator? The acid form or the base form? It must react with the base form of HIN, which is IN. What's the base form? IN minus. So we have HCl. Okay. I'm just going to circle things for a minute and then I'm going to get rid of the circles because it's irritating. Okay. So we got HCl and it is reacting with the base form of the indicator. And because it is an acid, what does it do? It donates a proton. So it's going to give its proton to IN minus. Yes. And that means that IN minus becomes HIN. And HCl becomes Cl minus, its conjugate base. So far, so good? Now, when we react these two things together, we are told that we see the color red. So, which species is red? Remember, HCl is what kind of an acid? It is a strong acid. So if it is a strong acid, this arrow is what kind of an arrow? One-way arrow. So who are the only species present? And when I say in that well, I mean in the little depression in the thing. So once we've reacted these two things together, who are the only things present? Who are the only species left? Cl minus and HIN1. What color do we see? Well, we're told that when we mix HCl And indicator 1, we see the color red. Yes? So when we do this, we see the color red. So which species is red? HIN1 or ion 1 minus? HIN1. So this is how you go about figuring out which color each form of the indicator is. You say, what does it do with the HCl? What does it do with the NaOH? Now, NaOH is it's a strong base. So when we put it with the indicator, the HIN1/IN1 minus, which form will it react with? It's going to react with the HIN1. So NaOH reacts with the acid form. And remember, this one was red. Yes? And what do we get? We get NaIN and H2O. And what color do we see? Let's go back to our table. What color do we see when we mix NaOH with the indicator? We see yellow. And I've circled in red, that's awkward. It is yellow, okay? So we go back here and we say, all right, that means that ion minus must be yellow because we see yellow. And because this is a strong base, what do we know about this reaction? It is a one-way arrow. It goes to completion. Okay, one-way arrow. So all we've got, the only species we have in the well are the IN1 minus and the water. IN1 minus and water. So who's yellow? IN1 minus. Okay. Huh? Is what a strong acid? NaOH is a strong, oh, thank you. NaOH is a strong base. I need to fix that. Okay. Whoopsie. I'm obviously cutting and pasting here. And so now we can go over here and we can say HIN1 is red and IN minus is yellow. And now we can look at what happens when we put HA1 and HIN1 together. What we're really doing is we are really mixing the mixture of HA1 and A1 minus plus HIN and I1 minus. Who will HA1 react with? It's an acid. It's going to react with IN1 minus, right? And A1 minus reacts with HIN1. There we go. Okay. So we can either write the reaction one of two ways. HA1 plus IN1 minus. Now, is HA1 a strong acid or a weak acid? It's weak acid, so we're going to get an equilibrium arrow. How do you tell? Because I told you that they are weak acids. At the beginning, I'm like, you have 3 weak acids, HA1, HA2, HA3. Yes? Okay. And so we get as our product, who would our product be here? Tell your partner, who are going to be the products of this reaction? We're going to have A1 minus because it has to donate a proton to ion 1. And then our other product is HIN1. The other way we could write this reaction is we could say we have HIN1. We could make that the acid. And we could react it with A1 minus. And then we would get the opposite reaction happening. We would get IN1 minus plus HA1. So both those reactions are happening. One is just the reverse of the other. Yes? But when we wrote our first reaction with the HCl, we said, let's have HCl react with IN1 minus, and it goes one way to give us HIN1, which we discovered was red. Okay, and we remember that IN minus is yellow. Now, HCl gave us the result of red. HA1 with the indicator gave us the result of red. Which side of the equilibrium is favored? Which side of this equilibrium is favored? Reactants or products? We saw the color red. Products are favored. And if the products are favored, who is the stronger acid in this equilibrium? Do you remember that? Which side is favored, the stronger side or the weaker side? The weaker side. So the products are weaker and the reactants are stronger. So we have stronger over here and we have weaker over here. So if we're comparing the two acids, which acid is the stronger acid? HA1 is stronger than HIN1. Okay. Now, I kind of, there's some extra walking through here that we can do, but you can just say, okay, I have figured out that HA1 is stronger than HIN1. Yay. Now, could you figure out who is the stronger acid, HA2 or HIN1? You can work your way through that entire process again. Yes, except using HA2 instead. Or you can look and say, HCl is stronger than indicator 1 and it turned it red. HA1 was stronger than indicator 1 and it turned it red. So HA2 turned it yellow. Is HA2 stronger or weaker than indicator 1? It's weaker because stronger acids turn HIN1 red. Weaker acids will turn HIN1 yellow. So if we have yellow, that means that HA2 is weaker than HIN1. It does the opposite of the strong acid, right? If you're doing the same as the strong acid, you are stronger than the indicator. And that's where we're going to get to today, because we're out of time. Okay. And we will leave it there. You all have your review. Oh, your quizzes. I have questions 1 through 3 marked, and I've almost finished 4 and 5, but I haven't yet. But here's the deal. I photocopied the quiz for you with the questions marked up to number 3. And questions 4 and 5 were actually the most well done questions on average. So you don't have to worry as much about questions 4 and 5 anyway. Okay? You'll get those back on Monday. So Caitlin, Kim, Yufei, Nadia. And I'm sorry it's black and white, but you know, you'll have to live with it until Monday when you can get a color copy back. Younghyun. Kira. Tiffany is not here. Ella is not here. Yoon. Ashlyn. Hayden. What? Yes. Jeff. Chair. China. Yeah. Cassia. Christina Agno. Catherine. You get to keep this. It's yours.
Thank you.
Atrin. Timmons. Charlene.
Oh my God.
Yeah. Charlene. Christina Wang. Not here. Sion. Yuri. Did I miss anybody? I don't think so. There you go. Because I haven't finished marking 4 and 5 yet. This is a photocopy of your actual quiz. So what your quiz is still over here in this pile.
Yeah.
Yes. So I have marked question 1 and 2 and 3, but I have not had time to finish these ones. So I photocopied it so you can have it back for feedback over the weekend.
I'll get it.
You'll get the rest of it on Monday. Yes.
Thank you.
Hi.
One whole more than this.
Yeah. Because there's a full molar there.
I did add few.
That's a half a mark and that's a half a mark.
What about your 0.25 mils? Those are. Okay. I did this.
Mm-hmm. Hi. I'm not finished marking these. That's why you're not getting the whole quiz back. You're just getting questions 1 through 3 marked back. Yeah. They will be marked by Monday. In fact, they might even be marked by after school if you were to try that, but yeah. Yes.
You are kind of sorry. How are you doing?
It's Friday.
It is Friday. Oh, yeah.
Yep, it's all good. Yep, for the day out now. Bye, Miss Ryan. See you on Monday. See you around here where the
your grant card, the property on the PM day. Oh, yes.
Yeah.
Yeah, but you're
Oh, this is not.
You're right on the cloud. I know, thank you. I know how this works.
Yeah.
Don't think you. Okay.
What?
I did.
Five?
Science is like, no way. That's funny. Where would I? Go through it again.
I forgot to ask. But
Yes.
could you sign this?
Yes.
It's not till like way later, but yeah.
Okay. Just remind me.
Yeah.
Yeah, perfect.
Thank you.
You know what?
Hi.
Stapler that would work on this.
No. Would you like a duotang?
What is that?
It's like the little thing with the 3 prongs.
I think you can text my voice if they want more. You will have to see my.
Yes.
Hi.
I'm not sure. So I photocopied everybody's quiz with the first 3 questions marked. I did make the rest to finish over the weekend, so you'll get the first 3 questions marked back today, and the rest of it back on Monday. Because I would like you to have as much feedback as you can over the weekend, but I was unable to mark all of them, all the questions. But I did mark everybody's first 3 questions.
Oh. How can I still be tired? I slept a lot last night.
But before you leave work tired, you
Sometimes it's true. It's true.
like 5 to 6 hours.
Uh-huh.
I'm awake around 6.
Yeah. Yes. There you go. So folks, I have the first 3 questions of your quiz marked. Okay. So what I did is, because I could not finish questions 4 and 5, I will finish those over the weekend. But I thought it would be nice for you to have feedback. Am I correct? So I photocopied your quiz with the first 3 questions marked. So I'm going to keep your original quiz so I can finish marking it. And then over the weekend, I will have the rest of it, questions 4 and 5. I've started marking some people's 4 and 5, and in general, they were better done than some of the other questions, so that's the good news. Okay? All right, so listen for your name to get your quiz back. And Aaron, you'll need to just not show it to Daniel because he hasn't written it yet. Okay? But it's not yours yet. Okay. Jenya, do you want on? Kylie. Isaiah. Dorsa. Are you kicking him out?
I didn't kick him.
Okay. Oh, you're Jonathan today. Okay. Samira. Hannah. Hannah not here. Laura. Not here. Jonathan not here. Aaron. There you go. Sarah, no Sarah. Jody. Ellie. Hiya. No Michelle. No. Oh, Cocolin, you're on here. Yeah. Did I miss anybody? Everyone got theirs back? Okay, good. And Ryan, what have I done with yours? Did I not mark it? What have I done with it? Oh my God. Did I put it in a different pile?
What would happen if you,
If I lose a quiz, I just omit it. It rarely happens. Very rarely. Why do I not have your quiz? What the hell? Hi. Yes?
I'm having trouble getting the 6.5 when you put a 5 or my calculator.
Okay.
Do you think you can help me with that?
Yeah, so what you're gonna do is you're gonna go 2.75 times 10 to the minus 3.
Yeah.
And then you're going to take the cube root, which is right there.
Yeah.
Shift.
I keep getting
Oh, it's probably not -3. That's probably what it is. Oh, let's see.
It was
Oh, I hadn't taken it in yet. Silly me. Thank you so much. Okay. Yeah, it's not, the power of 10 is wrong.
Okay.
What's the power of 10?
Is it the regular thing?
It's 13.
Oh, it's 13.
Yes, that's where that's where it is.
I just sold myself out.
Yeah.
13.
You didn't make it -13.
Oh, that's right. 3.05.
Okay.
13.
Yeah.
Oh, I see. Okay.
So Ryan,
No.
I'll get yours done before the end of class. Okay, so you will know. Silly me. I don't even know what I was thinking there. Okay. So folks, we are on page 11 today, but if you have any questions about your quiz, you can come and ask me beforehand.